Hello students, welcome to the subject Design Patterns, course code SAD 304. Today is our first lecture. In this lecture, we will go over with the basics and introduction of design patterns. So let's start with the course outline of this session. Firstly, we will see the introduction and the basic background knowledge of patterns. Then we will discover the history, the founders of patterns. Basically, few software engineers and experienced developers practiced different programming practices while implementation of their applications. So they discovered and they invented the good programming practices and have given them name. Then we will see that why the patterns are important, why should we implement them, why should we use them while developing different applications and softwares. Then we will see an overview of the design paradigm. Basically, the design paradigm have the main two approaches: the function oriented and the object oriented. So you have already studied these design paradigm in your object oriented programming, but we will also just take a quick overview of these two paradigms here. Then we will see the different categories of design pattern. The main categories of patterns are three. The first is creational, second is structural, and the third is behavioral. So we will learn the different patterns which will be falling in these categories. Just to give you a quick overview, the creation design patterns deals with the creations of object, the instantiation of object. Structure design pattern deals with the structure and the composition of objects, and behavioral design pattern deals with the communication between the classes. And we will also see the design pattern and learn the design pattern in their particular structure, because every design pattern has some specific format and structure. It has a few components such as intent, introduction, the collaboration, the participants, UML, representation, code implementation, and at the end conclusion. So we will learn each design pattern based on their specific format or structure. By learning the introduction and going through the background knowledge of design pattern, you will learn that the patterns provide you with a way to solve different repeatedly occurring issues related to software development, related to software application, using some proven solutions, proven programming practices. So design pattern not only brings standardization into your code, into your application, but also ensure that your code follows good programming principles. You know that in today's world, the programming and the coding, writing code is not a big challenge. You can search any piece of code from the internet. Whenever you type or search any particular piece of code, you can get the help from different sources. But the main challenge is to write very efficient, error free, bug free, and with the good handling of the memory. Your code should be handling the memory management. So the main challenge is not the programming, but to write a good, efficient, and bug-free code. So you will be learning good programming practices in this subject. These are the some reference books that you can download from the internet in the software form. Also, you can buy these books. These are easily available in market. The first one is the design patterns, elements of usable object-oriented software uh, by Arigama, and this book is basically written by the inventors and the founders of design patterns. The Arigama and these four authors are famous by the name or by the title of Django 4. These four experienced software engineers have discovered the design patterns. They were basically using some good programming practices in different applications. So they published their work and they have invented almost 23 design patterns, which are falling into three different categories, as I have told earlier: creational design pattern, structure design pattern, and behavioral design pattern. They have mentioned each design pattern in a specific structure that we will study, we will learn using the same structure, and they have implemented each pattern by taking an example of any scenario, any feature, any requirement, functional requirements from some application. So you will also learn the design pattern by taking an example of a scenario and by learning it from a code implementation. And the second book that you can also download from the internet or buy from the market is Head First Design Pattern. I am recommending these two books because they both are giving and using the scenarios from different applications, from different examples. So you can improve your design patterns, background knowledge, their implementation, and examples from different applications from these books. Also, there are also other books available in market and also on internet. You can search or you can Google out. So let's start with the introduction. Design patterns are nothing about a new technology or a framework. You might be thinking that in this session or in this subject, you will be taught a new language, a new framework. Basically, design pattern is not about a new technology, not about a new language. It's about using some basic object-oriented programming principles, which you have been learned in start of your semester or in start of your BS program. If you recall object-oriented programming or OOP subject, you have learned different basic concepts, different foundation, and the blocks of OOP, such as the concept of objects, the concept of classes, the concepts of putting the relevant methods and members inside a class, the encapsulation, abstraction, inheritance, polymorphisms, and so on. So you have learned those concepts, but the main thing is that you don't practice those concepts when you implement or you convert some features or functional requirement into code. So in this subject you will be taught that how you can practice these OOP programming these are OOP programming based concepts in writing your code. This is all about how and where to write the code, and why you need to do that, because it will ultimately improve your solution, your approach, and it will be fast with respect of its processing, its time, and the solution will be flexible. What is meant by flexible here? Flexible code means that you can alternate, you can change, or you can update the code whenever there is a requirement of new feature, or whenever there is a requirement of some change in your application. Then your solution must be enough flexible that you can update or you can insert the new code easily. Because mostly a developer just write the code so quickly without even thinking that it's flexible in future or not, that whenever the new change comes they have to change and they have to rewrite everything from the start, which takes much time, and sometimes the regression issues comes, and the developer mostly get tired of the testing again and again. So the your solution should be very modular, and your it should be very flexible. It should adapt the changes very efficiently. And the next is the chances of the errors will be reduced whenever you apply some good solution, whenever you write a very efficient code. Then the chances of bugs, the chances of crashes, the chances of errors will be automatically reduced. Being a user, just take yourself an example that whenever you search different applications for your mobile from the app store, then most the applications you find very interactive, very good, appealing in the sense of interface, in the sense of theme. But whenever you start using them, you start exploring their features, then most the applications start crashing, so you stop using those applications. Why this happens? Because maybe the software engineer, the developer have implemented all the features features which were required for the user, but but they haven't provided a solution with respect to considering the memory constraint, the time constraint, and so many things. So by practicing the design patterns, by practicing the OOP practices, the OOP concepts in your code, the chances of and the risk of your crashes in your app will be automatically reduced. Using the design pattern, you will see that your solution is imagined in a more real world way. Why so? Because you know that the concept which you have studied in object-oriented programming are also taken from the real world. Because you know that every real entity will become class, the object. Whenever you have to store the information of sub entity, something, then you compose it into a class like kind of structure. And similarly, the inheritance concept is also taken from the real world, that whenever you want to distribute the features, distribute the some qualities from one class to another, you use the concept of inheritance. So similarly, the design pattern will also implement the solution in a more real world way. You will also learn just to see their name of the pattern. The name of the pattern is so catchy and so easy to understand that what you can easily pick from the name that what this pattern is doing. So, in this subject, we will identify, we will learn some good programming practices, and we will call them names. So, it means that you have some scenario, you have some requirement, you have some module, and if you practice or if you implement through some standard method, then it will be given a name of a pattern. So let's see the formal introduction of patterns. A pattern of object-oriented analysis and design principle which can be applied to multiple problem scenarios is called a design pattern. What is meant by here the multiple problem scenarios? If you have experience of developing or writing the code in different applications, you will see that the repeatedly same situation, same problem, same requirement will be occurred. Such as, for example, you are going to design an application for an e-commerce app. You will see that there are different features, including user login, including database connectivity, and so on. Similarly, let's say you are going to develop an application from a university or some student management system. The same requirement for the user logging and the database connectivity will be again required. So if you implement that particular situation or the feature using some standard pattern, then you can apply that pattern into multiple problem scenarios. And these standard methods will be using object oriented principles in their backend. As I have told earlier, that you will not be taught a new technology or a new concept, but you will use the same object oriented programming core foundation principles which you have been already learned. But because of your lack of practice, because of your lack of thinking, or because your lack of development experience, you are not able to sometime apply those concepts while writing the code. So you will be taught good programming style while practicing these patterns. So design pattern is nothing but a good object oriented analysis and design and given a name. It means that each pattern is given a name. It means that if you have a scenario and you implement a inheritance in some way, then it's a pattern A. Similarly, different programming concepts are based on OOP programming, and it's also given a name. Okay, next we will see that what is design pattern. In software engineering, a design pattern is a general repeatable solution to a commonly occurring problem in software design. As I have already explained this, that your applications, most applications have sometimes have same requirements, same features. Once you implement them, you can easily implement the same solution into different applications. For example, I have given the example of login problem, the login scenario, login feature, also the database connectivity. Similarly, in your all, for example, e-commerce apps, you have to implement the shopping e-cart functionality, checkout functionality. So your applications mostly have the repeatable situations. So if you learn to practice some good pattern into the scenario, into one scenario, then you can implement the same scenario using the same pattern. A design pattern is not a finished design that can be transformed directly into a code. It means the pattern is just like a template. It's not a finished form of your code for a particular feature. It gives you an initial idea. It gives you a template that how you can map that feature into the code. So it's give you some basic steps. It gives you some basic structure of converting features, converting scenario into code or its implementation. It's a description or template for how to solve a problem that can be used in many different situations. Just to give you an idea that how the what template is. For example, if you are asked to write a proposal for your final year project, then if you in start of your write up, you will ask your teacher or the senior students that what is the format of proposal, or you will ask from your supervisor that how you can start write up for your proposal, because as a beginner you just don't know that what is the proper way, what is the proper method. So your supervisor may or your senior may provide you a basic template that this using this template you can easily you can easily add up, or you can easily fill your contents according to your idea into this template. So basically templates makes your work your makes your writing in a more appropriate way. Similarly, patterns are just like a template for different situations. Let's say template 1, template 2, template 3. They are different kind of templates, and 23 basic templates which are founded by Django 4, the book which I referred already in start of this session. So using these template, you will get an idea that how you can implement a particular scenario using some standard pattern. Almost 23 design patterns are invented by Gango 4. As I've already told you, the book first written in the reference section is also written by these Gango 4. So you will learn 23 design pattern in from different categories such as creational, structure, and behavior design pattern. Next, we will learn that why we should practice design patterns. Design patterns improves code usability. These are almost the same features, the same usability purpose that you have learned in object-oriented programming. The same advantages which you have studied in OOP are also being practiced in design patterns. By implementing the patterns, your reusability of the code will be increases. What is meant by reusability? That you can use your piece of code, you can use your solution, your implementation into different applications, into different places, into different classes. So and also to design a new software system quickly and efficiently. It means that when you start, or when you are a beginner and you are at initial steps of development, then mostly you get confused, mostly you are thinking that how to start and which approach you should use for implementation of particular scenario. So so patterns are basically the recommendation of experience and the experts of engineers, that if you have this scenario, then use this pattern, and if you have this problem, then implement this using this style of code. So the next is the design pattern will improve you to understand the existing software system or application. Why there is a need that you need to understand some existing software system? Because let's say when you start your job and you join a software company, then it's not like that they will give you or assign you a new project from scratch. They will adjust you in some team which is already working in some idea or in some project, and they will ask you to implement some feature, some new feature, or will ask you to change something into existing application. Then you will add up your code, or you will change the code. But firstly you need to understand the existing code, because you cannot update, or you cannot add a new feature until you understand the existing structure of the application. So If the existing code is scattered and it's not using any standards or any format, then it will be very difficult for a beginner or for a person to learn from the existing application. But using the design patterns, if the application or the project is developed by using the patterns, then it's so in a well structured form in a that you can easily learn the existing application. And the next point is that the patterns give the developer, the software engineer, a selection of tried and tested solution to work with. Why so? Because I have already explained that these patterns are founded by some expert software engineers. They have implemented different scenarios using some OOP-based concepts, and they have tested it. They have tested it very extensively. So these are some good recommendations by the expert developers, and that they have proven track record with the success stories. So you can easily implement your project using these patterns. The patterns are language neutral and so can be applied to any language that supports the object oriented programming. Why so? Because I have already told that pattern is not a finished code, but it is a kind of just like a template. So, language neutral means that just like OOP is not a language, but OOP is a concept which you can apply into different languages. Like you can apply OOP's concept in Java, in C++, in Python, in PHP. Similarly, you can apply the patterns in different multiple languages. It means these are the templates which you can adapt into any language, into any domain, into any kind of application. It's not like that you cannot implement the pattern for mobile applications. You can use and practice the design pattern for the development of desktop application, for the development of web application, for the development of mobile applications. So they are very generic solutions. The next thing is that they have a proven track record as they are already widely used and thus reduce the technical risk to the project. And I already explained that using the design patterns, when you implement, you write the code using some standard methods, using some recommended approaches, which are already being practiced by experienced and expert software engineers. Then the risk of failure for your application, the risk of your product of failure will be automatically reduced. And the design patterns are highly flexible and can be used practically in any type of application or domain. As I've already told you that you can apply the design pattern in any kind of application, regardless it's mobile, regardless it's desktop, it's web. So any kind of application in any language which support OOP, you can apply the design patterns. Next is basically this is the basically summary of few features that why you should consider applying the patterns. Design patterns produce quality, and how the quality is basically measured in different angles or from different perspective. From end user view, the quality means that your application is in a good performance. When you are using that application, your application is crash free, bug free. It's consuming the memory and your devices resources in a very efficient way, and plus your application is available in you can easily access to that application. It's available in App Store. And usability means that your application is very good in terms of affordance and perception. Any user can easily learn by the look and feel and the appearance of that application. The next point is very important, that from the user end, the security is very critical matter. If your application is not secure with respect to the private and the personal information and the data of the user, then the users and the client will stop using that application. So these are some quality perspectives from the user and if you implement the design patterns, automatically these quality parameters from user end will be improved. What is meant by or the quality means from the developer end. If your application or your project or your code is good or it's of good quality, then it should be maintainable means you can easily maintain, you can easily update, alternate that code when the requirements changes, when the feature add up. And your solution should be portable. What is meant by portability? That you can easily use the same solution, the same approach, the same code for different portable devices. Like if you have developed an application for a web, then you can easily convert or transform it for mobile application. Reusability means that I have already told you that many of the scenarios and many of the situations and the features are repeatedly occurring in one application or in multiple applications. So if you have implemented a feature using some standard method, then you can easily implement the next time the same feature with the same practice. So your code should be very usable. Testability means that your project should be in a modular form, in a well structured format that you can easily apply the testing parameters, easily apply and experiment your testing. So by implementing the design patterns, these parameters, these quality concerns will automatically be taken care of. And from the business community, the quality parameter are different. For example, they are very much concerned about their time to market, their cost and benefits, the projected lifetime in application, targeted market, and interaction with the legacy system. What is meant by legacy system? It means that if a client is asking you to develop or convert some existing old manual system or old system into using new technology, then his old system should be automatically and easily convertible into the new system. It doesn't mean that the client old data will be wasted or will not be able to export or import. So your new system should be easily integrated with the old system. The new system should be able to provide the features for importing and exporting the old existing data and all kind of features. Design patterns are basically in some standard structure or standard format that you should learn. Each pattern will have some intent. The intent is basically the purpose and the need of the pattern for solving some issue or a situation. So you will firstly understand the intent of any pattern. Then there will be motivation behind of using the pattern for some kind of functionality. So you will learn different motivations behind of using the pattern. Then the solution options, as we know that in uh, sometime when you have a problem, then different kind of approaches comes into different minds. So sometimes you have a problem, but there are multiple solutions and the multiple ways to solve that problem. So you will see that the design pattern also provide the multiple solutions to a commonly occurring problem. Optimal solution, you will see that sometime when you have multiple solutions, then we will learn that how we can use optimal solution by using a more recommended pattern, more recommended approach for the implementation of a particular problem or a feature or a scenario. The next thing in the structure of the design pattern is the human representation of a pattern in a some scenario. Because in software engineering programming, you have seen that there are different modeling schemes, there are different diagrams, there are different representations which you practice to convert the written text feature requirements into that modeling. So similarly, we will also learn that how we can design a UML representation of any scenario using a pattern. We will also learn different disadvantages and the shortcomings of using a design pattern in some cases. And then we will also learn the examples of a scenario by converting from UML representation to the code implementation. So each design pattern, inside the each design pattern, you will also see the basic code implementation, the basic format and the template for solving a particular scenario. The next is the type of design patterns. Initially, the Gang of Four have founded and invented 23 design patterns, but now From that time, many design patterns have been proposed and developed. There are more than hundreds of design patterns falling into different categories, but these are some basic design patterns. If you have learned them, if you have practiced them, if you have implemented them, then you can easily learn any design pattern, because these are some basics design pattern which are from three categories. To explain these categories, let's start the creational design pattern, structured design pattern, and behavior design pattern. Firstly, what is the creational design pattern? What are those? The creation design pattern basically deals with the creation of classes. If you remember that when you implement or you write some scenario or you write some feature, you compose classes, you write classes, you and then to invoke the functionality and the methods of classes. Firstly, the first thing you have to do is create the class object, or it's called instantiation. So from till now you are doing that, you are creating and instantiating the objects at any class, at any functions, but now you don't need to do it everywhere. There are some specific patterns particularly which are dealing with the creation mechanism. So you have to create and instantiate the classes by learning that how what is the standard way and what is the recommended approach to instantiate particular objects. So there are many design patterns which are dealing with the creation mechanism. You will learn one by one. The next category is a structured design pattern. Structured design patterns basically deal with the structure of the classes, the format of classes, the composition of classes, the relation between the objects and the classes. So it will improve your existing structure of your class. The next category is behavioral design pattern. How you invoke and how you induce the behavior in your application. If you recall that you write and you invoke the methods among different classes. Let's say you have to communicate three or four classes, let's say A, B, C, and D. Then how you can communicate between A and B? You will invoke the methods of B inside the class A and by passing some information in the form of parameters. Similarly, the behavior and the communication mechanism will be dealt with by the behavioral design patterns. You will learn different design patterns in also in this category. These are the basic listing of 23 design patterns that are proposed by the Gang of Four, and you can easily clearly see their division in creational, structure, and behavioral category. The blue boxes shows the patterns which are in creational category, the brown and the structure category, and the green in the behavioral category. If you start reading their names, then they are so taken from the real world that you can get an initial idea that what these patterns are about and what they are doing. So, and we will learn these patterns one by one in our this subject. Next, we will take an quick overview of the design paradigms. There are basically two design paradigms which are already being practiced and used. The first is the structured design paradigm or the function oriented design. The second is object oriented design paradigm. You have learned these paradigms before starting the object oriented programming or in the OOP subject, but to just starting the patterns, I will give a short and quick overview of these two paradigms. Let's see first the structure and the or the procedural design paradigm. It focuses on procedures and functions. It means that when you develop or when you code or implement an application using the function oriented paradigm, you focus on procedures, functions, and methods. The next thing is the global data. Why the global data? Because different functions have to access the data and the methods. So you have to write, you have to declare, and you have to give access, global access to the data, so that many functions can access the data at any time. design the system by decomposing it based on processes and functions and the global data. So this approach separates the data from the procedures. You can see that your functions or the methods are not linked with the data. It's not like that your functions have their own data. The data is global, and any function and method can access the data at any time. But there were some limitations and there were some issues in this paradigm. That's why you have moved to the principles. So let's see what were those problems. The drawback of using the function or the procedure paradigm was the interdependencies between various functions and processes. Your different procedures are interdependent with each other. Why so? Because it might be possibility that at the same time different methods need a same data. So what to handle in this situation? So there were dependencies. And similarly, this approach cannot be used easily. Why so? Because you have to every time access and write the functionality because the data is scattered in your application. Data is not linked with the procedure, and data related to each function is not attached. Design patterns are totally based on the building blocks and the basic concepts and the foundation of object-oriented programming. So these are the some basic pillars and the important points that you have to recall, because to understand the patterns, it's very necessary that you recall the basic concepts of OOP. So your OOP is based on these points: objects, classes, data encapsulation, inheritance, polymorphism, message passing, and the other three pillars of object-oriented programming are encapsulation, inheritance, and polymorphism. So these are some basic foundations in OOP concepts. You have already studied them in OOP subject, but the problem is that you are not capable of practicing and using those concepts when you have to write the code, when you have to develop the application. So you will learn in the subject that how you can practice, how you can use these concepts using some standard method and using some standard approach for the implementation of any feature, any requirement in your application. These are the same benefits that you have already seen in OOP, that your these concepts will improve the encapsulation, data encapsulation procedures, and in objects and class structure. The dependencies can be easily handled using inheritance and polymorphism, and the OOP provides the solutions in the more real world way, and the reusability of existing classes will be increases in your design. From the list of the main pillars of OOP, let's see the first pillar, which is object. Object is the basic and the runtime entity, the representation of the information in your application or the system. Let's say, for example, you are going to design a system for your university. Let's say attendance system. Then you have to firstly extract the entities. So what are entities? The entities are teachers, students, rooms, the faculty, the department, and so many things. So when you have to represent them in your application, then you will create the classes and you will create the objects. So objects are basically the user defined data type, the user defined information. They may represent a person, they may represent a place, or any other thing. Program objects should be chosen such that they match closely with the real world objects. Objects take up the space in memory and have an associated address like structures in C. When a program is executed, the objects interact by sending the messages to one another. This is an example of object. The object is student, and this is the next structure. The next box is representing the data, the information that you have to store about the object. We know that student have ID information, it have the name, marks, emails, and so many things. The next box shows the functions and the method, the functionality or the processes that we have to implement or perform for this entity. So inside this structure, the structure of object, you are seeing that your data is attached with the functions, which were the drawback and the limitation in function oriented paradigm. Here you can see that the object is linking the data and the functions, the relevant functions are attached inside this entity. So what is class? Classes are basically user-defined data types and behave like the built-in types of programming languages. Objects are variable of type class. Once a class has been defined, we can create any number of objects belonging to that class. So basically, you have learned the some predefined and the built-in data types. For example, integer, for example, array, structure, and so on. But if you have the representation of entity, then you compose into object, and the class is the user-defined data types, which is used to link the information of entity and its processes together inside the class. After the object and the class structure, the next is a very important concept, which is the communication between the objects. The objects communicate by message passing. What is meant by message passing? That let's say there are two objects, object A and object B. How they communicate with each other? They invoke the functionality of each other, and they pass information through the parameters, through the parameters of the processes, through the parameters of constructor. The name of the service requested by the calling object is passed through the messages, and the copies of the information required to execute the service and the name of a holder for the result of the service. So this is the example of the parameter passing and the method invoking. In practice, messages are often implemented by procedures calls, and how the procedures are called, they have some name, the procedures have name, and they carry the information and the parameter list. This is the example of a class. You can see that the student is an object, and it has information in form of its attributes, and it have the functionality in the form of some methods. And when you write the class for that entity, for that object, you can see that there is some public data, there is some private data. It shows that how much accessibility you want to implement. So you can have different accessibility specifiers such as public, private, and protected. Similarly, inside the class you can write the functions, and this is how your class is represented. The next concept is encapsulation. The wrapping of data and functions into a single unit is known as encapsulation. Encapsulation is just like a capsule that you put a medicine inside the capsule and it's encapsulated. No one knows what's inside it. And similarly, the class is the user defined data types is encapsulating the relevant information, the relevant data, the relevant attributes, and the relevant procedures inside it, because the class carry for example, you have seen the class of the student. So this is carrying the information of the student plus the different functions and the processes that we can implement for this entity. So the data is not accessible to the outside world, and only those functions which are wrapped in the class can access it. You can revoke the access by making it private, by making it protected, or give the access using the public specifier. This is the example of encapsulation. Inside this, you can see that there is class with the name of entity person, and it has some methods and some it has some attributes, the variables. The private shows that this password attribute is restricted for accessing outside of that box, and the public methods are accessible from outside this class. And this is how you can encapsulate the information inside a class. The next concept is inheritance. Inheritance is used for the distribution of behavior among the classes. It's a process by which the objects of one class require the properties of objects of another class. This principle behind this sort of division is that each derived class shares common characteristics, common behavior, common functions with the class from which it is derived. So in OOP, the concept of inheritance provides the idea of reusability. You can reuse the existing method, you can reuse the existing variables. This means that we can add the additional features to the existing class without modifying it, because modification of class of a class which you have already written for your own purpose in future is not a good option. Your classes should be extendable, your functionality should be extendable, so that you can add up or you can accommodate the new feature easily. So inheritance is very much practiced in OOP programming. This is the example of inheritance. You can see the person class is carrying its information in form of attributes, and the next class is employee, which is extending the functionality, the basic functionality and the functions of person, and it have its own attributes such as salary and other methods. You can easily access the methods of the person class, as you can see the name and the cell number. Similarly, the employee class is extending and inheriting the attributes, the functions, and the procedures of its parent class, which is person in this case. Also, another visual representation of inheritance, the different types of birds classes are can be implemented from the main or the parent class bird. You can write the own methods of child classes, but the child or the deprived classes are also carrying and will keep carrying the parent information from the bird class. The polymorphism concept is very interesting and it's very much used in every kind of pattern. So you need to really understand the concept of polymorphism. It means that your object have polymorphic behavior. It can vary based on the different situations. Your object and your the class can change the behavior at runtime. So the polymorphism means the ability to take more than one form, exhibit different behaviors in different instances. The behavior depend upon the type of data used in the operations. The concept of polymorphism is totally based on inheritance. Here, let's say this geometry representation show the shape, a main class, and the child classes are triangle, rectangle, and circle. The shape can have three forms. The polymorphic behavior of the shape is defined by using the concept of inheritance. The shape can be triangle, shape can act like a rectangle, shape can be circle. So it can have as many forms as you can write the child classes of this class. This is a code example of polymorphism. Let's see. The class animal has, this is in C or C++ code. You can easily understand this. The class animal has a virtual method of with this name meow, and inside this there is a cout. The next class is animal class, which is the child class is cat class. Cat class is inheriting the functionality of animal class, and it's overriding the method from the parent class. And there is another cout thing. The next child class is tiger class, which is also implementing the parent class animal, and inside this the override method meow is has its own functionality. And similarly, the next child class is dog class, and it's also implementing the animal class. And the next method is calling the meow method of animal with the reference of the parent class. So basically, in this we have defined the polymorphic behavior of animal class in different kind of animals such as cat, dog, and tiger. So now we will see that how the animals can vary at runtime. In the main method, you can see that the instance of cat, tiger, and dog are created, and in the doing method, the references of the cat, tiger, and dog are being passed. The do mu method is calling the mu method from the animal class. You can see that how we have defined the polymorphic behavior of the animal. When the animal receive the reference of cat, the animal will act like a cat. When the animal in the second line of the doing method will receive the reference of its tiger class, its child class, the animal will act like that. So we have defined the three polymorphic behavior of the animal class. This output shown here give you the idea of polymorphic behavior of the animal. When the animal receive the reference of its child class, it acts like that. The animal is a cat if it's received the reference of the cat class. Similarly, so on. So you can define the polymorphic behavior of the animal by creating its so many child classes. For example, if there are 10 type of animals and you can define the 10 polymorphic behavior of the animal, then you have to write the 10 different classes. So this is the concept of polymorphism, which is totally based on the inheritance. So you really need to understand and practice the polymorphism, because each and every design pattern is based on inheritance and polymorphism. Just to give you the practice of this whole session, I have added this case study. Using this case study, just read the whole textual requirements. You have to convert these textual requirement by considering the two kind of paradigms which we have already discussed: the function oriented design paradigm and the object oriented design paradigm. These requirements are given in the text forms. You have to extract the information in the function oriented design paradigm. You need to extract the methods and the global data, which you can list for the functionality. And in object oriented paradigm, the information extracted will be based on object, classes, methods, the relevant functionality inside the class, encapsulation, and so on. The solution of this case study is listed in the end of this slide. After practicing this case study by your own, you can jump to the solution. Now you can see, using the function oriented approach, we have identified the global data from the raw textual environment, raw textual requirements. You can see that there is a detector status arrays which contains all rooms information. Similarly, the location of the rooms, the neighbor of the alarms, and the detector locations. These are the arrays because we have multiple and the collections of rooms and the collection of information inside this. In function-oriented approach, we have to identify the global data and as well the functions. So functions are listed in the next slide. Few of the functions we have extracted from the given requirements. You can extract more. This activity is totally based on your creativity. You can identify, you can extract as much as variables and the data you want to store, and you can maybe you are extracting different kind of functions, or you are extracting more than these functions, but these are the some important functions that you can extract from the given text requirements. For example, get detectors, get detector location, report file location, determine neighbors, ring alarm, and reset alarm. So using the function oriented paradigm, the important data and the functions are not linked and they are scattered. Next, this is the object-oriented approach. In this, you can see that your relevant data and your relevant functions are encapsulated inside the classes. So we have identified the two main classes. The one is detector and the alarm, and the attributes which are carrying the detector information are status, location, and neighbors, and the relevant procedures and methods are inside these operations. The next is the alarm class and their corresponding attributes and functions. So data is linked inside the class entity, the class structure, kind of structure. The main purpose of this activity for you is to practice that how you can convert the raw textual information into meaningful representation using the two approaches, function oriented and object oriented approach. Similarly, in the design pattern, the scenario and the requirements or the features might be given in the raw text form, and you have to convert them into UML representation and the code representation for the implementation of the design pattern. That's why this was the basic case study, so to gear you up for the next patterns implementation. So at the end, we can conclude that the design patterns are very important, just like the concepts of object-oriented programming. They are very language neutral. They are very domain independent. You can apply, implement in any language which support OOP concepts. I have given you the basic overview of the OOP concepts, so you can recall them. You can't learn the design patterns until you are very much clear and you have the practice of object-oriented programming. This course is the theory course, but we will learn the design pattern into their format and the structure, and we will also implement using the code implementation of a scenario. So design pattern helps you choose the design alternatives. We have seen the different advantages of using the design pattern. We have seen that why we need the patterns. The patterns improve the reusability, the flexibility inside the code. It makes your application bug free, error free, and the crash free. Design patterns can improve the documentation and maintenance of the existing application, and design patterns helps the software engineer to develop an application more faster. So these are some of the basic introduction of the design pattern, and in the next session we will start learning each pattern one by one.